All right. Good morning, party people. Welcome back to geometry. This is your second day of notes before we dive into our performance on Wednesday, Thursday, Friday. Last class, we talked about complements and supplements of angles. Today, we are going to continue talking about those, and we are going to add on an additional angle pair. Our topic today is angles formed by crossing lines. Formed by crossing lines. And our essential question is, how can I solve problems using vertical angles and linear pairs? Okay, we are going to go ahead and dive right in. Our first one, angles formed by crossing lines, real simple box, just a couple sentences, just a sentence here. When two lines cross, they form four angles. You can see this in our diagram at the right, angle 1, 2, 3, and 4. Easy peasy. We can group these angle pairs into two types. The first type is linear pairs. Two angles are linear pairs if they are next to each other. So we would say these are angles that are adjacent, and form a line. So if we look over at our diagram, we have a bunch of linear pairs here. I usually abbreviate linear pairs as LP, but I'll write it out today. Our one example of a linear pair is angle 1 and angle 4. Another example would be angle 4 and angle 3. You could also do angle 1 and angle 2, or angle 2 and angle 3. You may notice that since these pairs all form straight lines, they are equal to 180. We had a special name for that yesterday. We said that angles that add to 180 are, feel free to check your notes, they are called supplements. Linear pairs are always supplementary. They always add to 180. Our other type of angles are vertical angles. Vertical angles are angles that share a vertex and use opposite rays. An example of vertical angles is angle 2 and angle 4. Another example would be angle 1 and angle 3. If you look at your diagram, 2 and 4 look like they're about the same size. Same thing with angle 1 and angle 3. Because of this, we have a conclusion that vertical angles are equal. This is a really powerful statement. It lets us say, without knowing anything else, that the two angles are equal. Let's work an example or two. Go ahead and pause the video if you need to. And now let's move on. Using the figure above, find the measure of all angles if you are given the following measure. I would recommend dividing this into two spots and then drawing the diagram in each. Doesn't need to be perfect. Y'all know Mr. O is not an artist. So we'll go around 2, 3, 4. I'll draw it again. 1, 2, 3, 4. All right. So if we look at our first one, they tell us the measure of angle 4, or the measure of angle 1, sorry, is 117 degrees. We can use this information to find the measure of angle 3. We know that 1 and 3 are examples of vertical angles, and vertical angles are equal. So if angle 1 is 117, angle 3 is 117. We can find angle 4 because 1 and 4 make a linear pair. Linear pairs are always supplementary, meaning they add to 180. So to find the measure of angle 4, we take 180, we subtract 117, do that math, that'll give you 63. So the measure of angle 4 is 63 degrees. And then, because 2 and 4 are also vertical angles, we can say that angle 2 is 63 degrees. See how quick and easy that can be? Also note, we do have, all we had was one angle measurement, and we could find all the others. Let's try the next one on your own. You are told the measure of angle 2 is 59. Go ahead and take a second to figure out the measure of the other 3. Okay, I got myself off a little early there, but hopefully you've gone through the math and you've found that the 3 other angles are 121, 59, and 121 for angles 1, 4, and 3, respectively. All right, let's solve some problems. Good news, we do have pretty similar problem steps to last time. First things first, we always start by IDing the angle pair. Vertical angles are easy because if you have vertical angles, you are looking for an X. If you have an X, you probably got vertical, you know you have vertical angles. Step 2, as always, you're going to write your equation. And then step 3, you are going to take your equation and you are going to combine any like terms. Hopefully feeling very similar to yesterday. Vertical angles do have a little shift that we're going to have to talk about, but we'll see that on the other side. Last but not least, next, you solve for X or whatever your variable is. And then 5, you will plug in to an equation. Okay. Feel free to take a second to pause the video here, get anything you need to written down. And then we're going to work 2 examples on the backside, 3 examples on the backside of your page. All right, let's go ahead and let's flip her over. We are going to start by looking at problem number 8, or no, 11. I'm good at numbers. And I also see that there are 3 problems 11 on there, one of which you probably did yesterday. I am so good at planning lessons. Okay, so we can cross off the second, actually, yeah, we can cross off the second problem, the third problem 11. We're not going to worry about that. My bad, y'all. Let's look at problem number 11, first 11, next. We have a whole bunch of angles. We've got some Y's, we got some X's, all that good stuff. We are going to start, our goal is to find X and Y. The good news is we can do it in whatever order we want. So let's say the left side of our paper is for X and the right side of our paper is for Y. So when I'm looking at this, I see right away that my Y's are across from each other and my X's are across from each other. So this lets me know that we have vertical angles Let's start by solving for our y's. Those equations look a little easier. We know that vertical angles are equal, so we can say 5y is equal to 7y minus 34. All right. Now, here's a problem. We haven't had letters on different sides of an equation before, have we? So we need to figure out a way to do it. The good news is that you can cancel a letter just like you would any normal number. I see, okay, I don't like two y's, so I want to get rid of them. My general hint is if one y has more stuff, you get rid of the one with more stuff. So I see a 7y and a minus 34, and then just a 5y. I want to get rid of the 7y because there's other stuff with it. So to get rid of a positive 7y, I subtract it on both sides. Those cancel. 5 minus 7 is negative 2y equals, all that's left is a negative 34. I divide both sides by negative 2. Y equals 17. All right. Easy peasy, not too bad, right? Let's look at solving for x. We have vertical angles again. So let's set up our equation. 9x minus 4 equals 8x plus 7. Now, you're probably like, Mr. O, they both have the same amount of stuff. They both have a variable number. Like they're the same. So what do we do? And this is my second piece of advice. You get rid of whichever one's smaller. So I see a 9 and I see an 8. I say, let's get rid of that 8. So to get rid of an 8x, I use a negative 8x. Those cancel. 9 minus 8 is 1. So we'll get 1x minus 4 equals 7. We're all good at math here. We know that if there's a 1 in front, we don't really need to write it. So we can erase that if we want. And now we're just looking to get rid of a minus 4. So we look and we say, how would I do that? What's the opposite? Oh, we add it to both sides. So we add 4 to both sides. We get x equals 11. All right. Let's do, for our next problem, we are going to do problem number 6. Problem number 6, we need to find the measure of DEC. DEC. So I look and I see, I've got my X shape, right? If I have my X, what type of angles am I looking at? They've got to be vertical angles. And I should have made this note on the last one, but Mr. Onofrio messed up. Happens to everyone. Vertical angles are equal. So let's set up our equation. Since they're equal, we're not adding them together. All we're doing is we're taking angle AEB equals AEB, angle DEC. Let's plug in our pieces. AEB is 6x plus 12. DEC is 2x plus 60. All right, same problem. We've got two x's. Talk with a neighbor, say which one you think we should get rid of. Okay. If you said next, you're correct. We can get rid of either at this stage. I like getting rid of the smaller one first, so I would get rid of the 2x. To get rid of a positive 2x, we subtract on both sides. 6 minus 2 is 4. So we get 4x plus 12 equals 60. Minus 12 on both sides. 4x equals 48. I'll take it up here. Last things to do, we divide by 4. X equals 12. All right. So are we done yet? Hopefully you said no, because we still need to find the measure of DEC. So let's trace it, DEC. Give me just a second here. Okay, folks, my apologies for that. One of your classmates had a question to ask and I had to go answer. All right, back to it. So we said DEC, we look at our equation, angle DEC is equal to 2x plus 60. We now know that x is 12. You can plug in that 12 and then let yourself do the math. Angle DEC equals 2 times 12 is 24, plus 60 is 84. All right, party people. There are still two examples on here. Problem 12 is very similar. Check your vocab. So is problem number 11. Check your vocab, and I want you to think, what do linear pairs have in common with supplementary angles? And how can we use our notes from yesterday to help us out on this one? This is your last video for geometry for the week. What I would like you to do for the rest of the day today, I would like you to solve problems 11, problem 12, and then I'd also like you to write in the summary. Once you are done, please put your note sheet in your binder and do what you need to do for the rest of class. If you have any questions, please feel free to ask Miss Rose. Pro tip, Miss T and Mr. Campbell are also pros at this stuff. They've both taken my class many times. I hope you have a wonderful rest of your day. I wish you the best of luck on your performance assignment tomorrow and Thursday and Friday. And if you need any help when I get back, we will absolutely talk about it. Have a wonderful rest of your day and goodbye.